This is section 7.4, Systems of Linear Inequalities. So with an inequality, you can have infinitely many number of solutions. So we're going to look at this. So determine if the ordered pair is a solution. You just plug it in like you do with just a regular linear function. So this is our x and this is our y. We need to know if that's greater than or equal to 15. Okay, so I can put that left side in my calculator. This one more time. That was -3. So that gives me 18. So is 18 greater than or equal to 15? Yes, it is. So it is a solution. Here we have an inequality and we have 4 different points. So let's start with plugging these in. So I have 6 times 0 plus 10 times 0. I'm just going to plug it in on the left-hand side. That gives me 0. Is that greater than or equal to 14? No, it is not. So this is not a solution. Let's plug in the -6 and +5. It's a 5 right there. Loot. Again, you can just put this in your calculator. I believe that's 14. So is that greater than or equal to 14? It is equal to, if you have the line underneath, that gives you the equal to. So 14 is equal to 14. So this is a solution. Let's plug in 1 and -2. You can throw that in the calculator. It's going to give me -20 actually. So 6 minus 20 is -14. Is -14 greater than or equal to 14? No, -14 is less. So this one is not a solution. And finally, let's try 6, 2. So that gives me 56. Is 56 greater than or equal to 14? Yes, it is. 56 is greater than, so this is a solution. So we have 2 of these points that will make the inequality true, therefore they are solutions. All right, we're going to have to graph inequalities. Go up. They want you to, though, use the 1-point test to solve the inequality, shade the solution. All right. So I'm going to show you what I believe to be the easiest way to do these problems. Okay. So I'm going to write the inequality, but I'm going to make it an equation. So I'm going to take out the inequality symbol and make it equal to. All right. So I want to solve for y. So I'm going to start by moving the 7x. This was covered in 1020. If you need a refresher, please get with me. I'm solving to get y by itself, so we can put it in our calculator to graph it. From there, I'm going to divide each one of these by the -4. -7 over -4 is +7 over 4x. Then 28 divided by -4 is -7. All right, so with inequalities, if it's a less than or greater than, you're going to use a dashed line. If it's a less than or equal to or a greater than or equal to, you're going to use a solid line. Either way, you're going to use the line tool. Okay. All right. So this one, that line is going to be dashed. So we kind of come over here, and I'm going to hit the little calculator icon right there. That pulls me over to a graph. Now I'm just going to do this real quick. If you already have something in there, that's okay. You're going to hit Tab, arrow up, Control, Delete. And then we're going to put in the equation that we got. I'm going to flip over real quick just to double check myself. 704x minus 7. All right. Make sure you arrow to the right to get the x to the right of the fraction bar. It does not need to be underneath there with the 4. Once you get the equation, you hit enter, and then it graphs it for you. Now, if your window doesn't look like mine, you don't have the 6.65 or negative 6.65, the negative 10 and the positive 10, just hit menu. You go to window zoom, and then just go down to zoom standard. It takes you back to a standard window. So I had 6.65, now it's 6.67. That's not a big deal. And that's how you go back to a standard window. So I need 2 points to graph this. So does anybody remember how to get 2 points? You hit Control and then the letter T. That gives you a table. That was Control and the letter T. You're going to need 2 points that do not have fractions. So let's use 4, 0, and 0, negative 7. Write those down. And sorry about that. Just want me to sign back into the Microsoft account. So it's 4, 0, and 0, negative 7. Let me double check that. Oh, just threw me off. Okay. All right, so we're going to use those 2 points to graph. The first thing you're going to do is, oh, just having a good day with this. All right. Okay, not what I wanted. Sorry about that. Cancel. Okay. All right. So the first thing you do is select this little line tool, and you just need to graph 2 points. I'm going to go over 4, down 0, over 0, and then down 7. Okay. And the line was dashed. That's an option in there to change the line to dashed. The next thing you're going to do, it looks like a paint can. Ooh, something like that. And I'll go over this at the end of the video. I will show you how to graph this in my math lab. You need to shade on either side of this inequality. So I like to use the test point 0, 0. Okay. So we're going to plug that into the original inequality. Let me scroll a little bit. So I'm going to plug in 0, 0. Like we did with the first few problems. All right. That's 0 minus 0. So is 0 less than 28? Is that true? Yes, that is true. That means you're going to click the paint can anywhere on this side, okay? And it will end up shading the whole left side because the point 0, 0 is a solution and it's to the left or to the top of that line. You don't have to click on 1, 1. You just click the paint can anywhere to on that side where 0, 0 is. So let's work on this one. We're going to start by setting it up as an equation. We want to solve for y. So I'm going to start by adding the 121 to both sides. The y can be on the left, the right, instead of the left. That's really irrelevant. We just need it equal to y. Okay. All right, and then from there, I'm going to divide everything by 11 to get y by itself. 121 divided by 11 is 11, and that's equal to y. That's the same as this. Oops. All right, so let's flip over to the calculator. The table's on here. Before you put a new equation in, you need to get rid of the table. You do that the same way you got it. You hit Control and then T. I want to put a new equation in, so I'm going to hit Tab. It's on F2. I'm going to arrow up to F1 because I only want one line in there. Then you're going to hit Control Delete. It will just clear the equation. If you hit Delete by itself and you accidentally delete the equal sign, you'll get something weird. Let me go ahead and do that. So, and so I hit Escape. Oops, it didn't work. All right, so you get this. That's not a big deal. You just hit Menu, Graph Entry, and then select Function. Okay. Arrow up, hit Control Delete. It will only delete the equation. So Control division symbol 8 over 11. Arrow to the right, put in X plus 11. And then hit Enter. Now it's up on the top left. It's irrelevant how good of a picture it is. We just need 2 points. So we're going to use the table. Control T. Ooh, I need, okay, 0, 11 and negative 11, 3. All right, so if we look at the inequality, it's a greater than or equal to, so that means my line is going to be solid. Zero, go up just a tad, a bit. 0, 11, that's 10. And 11 to the left and up 3. We said that was going to be solid because there's an equal to underneath it. All right, from there we need to determine which side we want to shade on. So again, I prefer to use the point 0, 0. Actually, I don't want anything that light. So we're going to use the point 0, 0 and see if it makes the inequality true. So let me scoot over just a second. All right, that becomes 0 on the left. So is 0 greater than or equal to negative 121? Yes, it is. So then you would click the paint can on this side. All right, so this one is a system of inequalities. So we are going to have to graph 2. They want you to find the corner point, which is actually just the solution to the system where they overlap. Okay. So we're going to do a couple of things here. The first thing I'm going to do is find the corner point where they overlap. So I'm going to go back to my calculator. And before I get out of here, I want to close the table out. So Control T, always remove the table. Now I want to go back to the calculator. You can mouse and click on that, or I like the little button to the left. Looks like a calculator. Takes me back to this area. So menu, algebra, solve a system of linear equations. And we're not ever going to change that. So just tab down to OK and click enter. You do have to put these in as equations. So I'm just pulling out the inequality sign and changing it to an equal sign. Okay. So the corner point is at -3, 7. So we're going to do the same thing we did before. I want to set up as an equation and solve for y. I'm going to start by moving my 6x here. If you want to put 32 plus 6x, that's fine. I just prefer the x up front. Divide each one through by 2. So y equals 3x. And 32 divided by 2, I believe, is 16. I'm going to go ahead and solve the second one. Setting it up with an equal sign. I'm solving for y, so let's move 30 first. If those cancel out, I bring down a -6y. From there, I'm going to divide everybody by -6. So 4 over -6, it reduces to -2/3. You can leave it as 4 over -6. The calculator doesn't really care. -30 divided by -6 will give me a +5, and that's going to be equal to y. From there, I'm going to need to find 2 points to graph each one of these lines. So I'm going to click my little calculator icon, get back to the graphing area. I'm going to hit tab and arrow up to F1. Hit Control Delete, put in the first equation I got, and hit enter. From this, I just need 2 points. So that's Control P. And we want ones that are going to fit on our grid. So -4, 4, and -5, 1. And that's the first inequality. That is going to be a solid line because it's a less than or equal to. So that's going to be a solid line. Let's put the second one in. So again, get rid of your table, Control T. I want to put in a new equation. So hit Tab, arrow up, Control Delete. You don't hold Control and Delete at the same time. You hit Control, then Delete. There's no like double key holding with this calculator. So -2 over 3x plus 5. Again, you could have left it as 4 over -6. You actually could have put -30 over -6. It's really irrelevant. So I'm going to hit enter, and that's my new line. All right. Control T gives me a table. So I have a point at 3, 3 and 0, 5. So I have a point at 3, 3 and 0, 5. Looking at that inequality, it's just a greater than, and there's no line underneath it. So that line is actually going to be dashed. So let's do the first one, -4, 4. Let me link my point real quick. I don't know what I keep hitting to get that. I'm sorry about that. All right, I had a little uh-oh here, so I'm going to get back to it in just a second. All right, I accidentally closed it out, so I just put back the points that we had. -4, 4. I don't know. Okay. And I believe it was -5, 1. And we said that line was solid. Let me scoot up just a little bit. All right, so the next one was at 3, 3 and 0, 5 over 0 up 5. And we said that line was dashed. Let's see what our corner point was, right? Corner point was at -3, 7. Now I'm graphing this by hand. So 1, 2, 3, 6, 7. This is actually a point where they'll intersect. That's the corner point. When you graph in my math lab, you'll see it a little bit clearer. All right, so now we need to figure out where to shade. We do actually have 4 different areas. Okay, so it could be shaded here, 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 or here. Basically, what happens is where the blue line shading and the red line shading will overlap. Again, the easiest way is just to use test points. So I'm going to start with 0, 0 because it's the easiest point. It would have to make both of the inequalities true. So let's start with that. Scratch work. Is that less than or equal to 32? All right, so it's good for the first one, but it also has to make the second one true. It goes away. Is 0 greater than 30? No, that's not true. So that area, remember you can pause these videos. Let's come back over here. So we don't want to click the paint can anywhere over here, okay? Because it only made one of the inequalities true. So let's pick another one. Let's go to the left, to the right. Check this area, it didn't work. So how about over 1? Let's pick this point here. Actually, so over 1, up 1, 2, 3, 4, 6, 7. So randomly picked a point over here on the top right. So let's try 1, 7 in both of these. Is that less than or equal to 32? So -6 plus 14. I'm feeling like it's 8. All right, so that's true. Let's see if the second one is true. So we have 1, and I'm plugging in a 7. It's 4. 6 times 7 is 42. Is 4 greater than -12? That is true. Since both of those are true, you're going to click the paint can right here, and it will actually shade. So any point in this area that you were to use would make both of these true, but both of them have to be true, not just one. All right. So let's do this one. We need to find the corner point. Again, I like to just solve system of linear equations. When you graph them, in my math lab, the corner point will be really obvious because the lines will be straighter than drawing by hand. So again, we're going to change these to equals. So the corner point is at 1, 1. So we're going to take the first equation and we're going to solve for y. We're going to move the x term first. So then we're left with 3y equals negative 6x plus 9. From there, I'm going to divide each one of these by 3. Negative 6 divided by 3 is negative 2. 9 divided by 3 is 3. Now, for x equals 1, we are not going to be able to graph that in the calculator. So no matter what y is, x is always 1. So you could do 1, 5. You could do 1, negative 6. X is always 1 no matter what y is. So we do need to find 2 points for the equation on the left. So click our little calculator to get to our graphing area. And I did not close that table out. Tab, arrow up, Control Delete. And we have what? Negative 2x plus 3. And hit enter. I need 2 points. So Control T. There's lots of points here. 3, negative 3, and negative 1, 5. Oops. Looking at the inequality symbols, neither one of them has a line underneath it, so both of these lines are going to be dashed. You can get different combinations. So this one's going to be dashed, and this one is also going to be dashed. So over 3, down 3. And then, so let me double check my numbers. At negative 1, 5. And we said that one was dashed. All right, so x is equal to 1. Again, that one's also going to be dashed. Over 1, up 5. Over 1, down 6. That line is going to be dashed. So again, we're going to have 4 different areas that we could possibly shade here, 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 or here. Again, I always like to start with 0, 0 and see what's going on right there. So that would have to make both of the inequalities true if I plug a 0 in. So let's plug in 0. Zero greater than 9. Nope. So we're not going to shade in this area. All right. Let's pick another spot. What about this one right here? This little sliver up here that's over 0. Up 5. So that is at 0, 5. Let's plug that one in. So x is 0, y is 5. Is 15 greater than 9? Yes. But it also has to be here. Our x is 0. Is 0 less than 1? Okay, remember we're going to go back to the original inequality. That is true. So that means the shading where you're going to click the paint can will be up here, just anywhere up in this little sliver, and it will shade it for you. Now we're going to look at a couple of word problems. An athlete is taking several supplements. Supplement A contains 2 milligrams of niacin and 75 milligrams of calcium. B contains 5 milligrams of niacin and 250 milligrams of calcium. The athlete wants to take at least 42 milligrams of niacin and 1950 milligrams of calcium. Solve the system and draw and graph a solution set. Okay, so we have supplement A and supplement B. Right. Sorry about that. So it was supplement A and B. Niacin and calcium. Supplement A has 2 milligrams of niacin and 75 milligrams of calcium. Supplement B has 5 milligrams of niacin and 250 milligrams of calcium. They want to take at least, so what they take is on the left, has to be greater than or equal to, and 42 of the niacin or 1950 of the calcium. All right. So it's going to be similar to the two that we just did. We just need to find 2 points on each of the lines. It's an equal to, so the lines are going to be solid. Okay, and there's our little graph that we're going to use. So let's set this up as an equation. And you don't have to find the corner point on this one. All right, so we're going to move the x term. And then divide out the 5. And you can just leave that as 42 over 5. Same thing here. We're going to move the x term. And then divide out the 250 quarters. It's going to be 3 over 10. And 1950 divided by 250. All right, I do need to do that one over here. Get rid of that. Control T, calculator. 50. I guess I could have just left as 19 over 50 over 250. You don't actually have to convert it. Plus 39 over 5. Okay. All right, from there, we're going to need 2 points. So let's go back to our graphing area. those in. All right. Doesn't matter how well we see this. We just need the table. We need 2 points. So I have one at 1, 8 and 6, 6. Let's put the second equation in and see what we get. Control T. And arrow up. Control delete. Then, oops, let me get the next one. Negative 3 over 10. Let me get that negative out front there. Plus 39 over 5. Let's do the table. All right, I did something wrong. These shouldn't all be 7.5, but I think I know what I did. Control T, tab, arrow up, and I forgot my X. That's better. So let's hit Control T again. That looks much better. We have 6, 6, and 1 and 7.5. All right, so 1, 8, and 6, 6. Over 1 up 8. Over 6 up 6. Again, that line is going to be solid. All right. And we saw that the other one also had the 0.66 on it. And I believe it was 1 and 7.5. So over 1 up 7.5. Okay. And the easiest way for me to tell you how to do this, I mean, you can do all the test points, but the one with the supplements is going to shade. They need at least, so they can have more than the red and more than the gray. So the area that would be more than the red and the gray, this paint can is kind of top right. Okay. And our last one here, we have a manufacturing company, and they have 2 models of entertainment centers, model A and B. And they have molding in hours. Model A has 10 feet of molding and requires 6 hours to make. Model B needs 12 feet of molding and takes 3 hours to make. In a given week, the company had 129 hours of labor and 334 feet of molding available. So the total molding, that's the one on the left, has to be less than or equal to 334. And the total number of hours they have available to pay for has to be less than or equal to 129. So we're trying to minimize our material and labor here, whereas we were trying to maximize the supplements. So it's going to be the same process. We're going to convert these two equations. We're going to move the x term first. And then divide each one by 12. All right, 5 over 6. I don't know what 334 over 12 is, so Let's get this. It's 167 over 6. All right, move the 6x for this one. Divide everybody by 3. Let's get this down just a little bit. From there, I am going to need 2 points. Each one of these. Calculator's a nice tool. You don't have to do a lot of trial and error to figure out which 2 points to use to graph these. So let's click right here, move my table, tab, arrow up, control delete. All right, I can't see it on the grid. That's not a big deal. I just need 2 points off of there. So 1 and 27 and 7 and 22. 1 and 27, 7 and 22. So if we look at the grid here, we have a 40 by 40, so we have a lot bigger numbers that we can use. Let's look at our second equation. Move the table. And we're going to put the next one in. So minus 2x plus 43. Again, I can't see it, not a big deal. Control T. Let's use 533 and 1415. There's not any particular reason I picked these points other than they fit on here. And so again, both of these are going to be solid lines. So over 1 up 27. Over 7 or up to 22. So second line, I'm going to make it a different color. So over 5 up 33. 2, 34, 33. Over 14 up to 15, 16, 15. This one's going to be tricky for me to draw. All right. So on this one, again, you could do a little trial and error if you wanted to. We're minimizing, so we want to use the least amount of materials and hours, materials and labor. So that's going to be less than or below the red and below the blue, or it's below both of them together. So you would paint can in this little area. Okay, so I am actually going to pause this for a second, and the next frame we will be on a homework problem. Here we are on a problem from the homework. I went ahead and figured out the 2 points so we can just dispense with all that. It's basically to show you how to graph. So you click to enlarge graph here. Both the inequalities have a line. When you select the line tool, it will default to a solid line. If you need to change it to dashed, you would click on this. So we need 2 points. So I'm going to go, I have the point 2, 6. And if you notice the box, click on it. On the top right, it'll tell you where you are. The second point is at 4, 9. And you don't click until you're actually on the point. You see it says 4, 9. Click. All right, so then I'm going to select the line tool again. I'm going to graph that second line. So I have a point at 2, 12. And then another one, I go over 8, up 15. I don't click until I'm exactly on there, 8. Little. There we go. It says 8:15. I click. All right, so then you need to shade using the paint can. All right, so we selected the paint can. I went ahead and worked this, and we're going to shade up in here. All right, so I had tried the point 0, 16 and made both of the inequalities true. So it doesn't have to be on the point 0, 16. It's just anywhere up here in that region. So I'm going to click, and you see it shades. Okay. Oh, I did it right. And what is the corner point? If you want, you can pop it out. You can see it is at 8. Looks like 8:15. You can solve system linear equations if you want. There's a little pop-up box I was talking about. 8:15. That's what it looks like. There we go. And that is it for this last section for chapter 7.